So this is the second group of the solvable groups of trigonometric integrals. So if we have powers of sines and cosines, so the first group was product of sines and cosines. So if we have sine raised to the power of m and cosine raised to the power of n, okay, so we need to make sure first that m is a positive odd integer. So this first formula is applicable to m, which is a positive odd integer, or the exponent of the sine function must be a positive odd integer. So 1, 3, 5, 7, etc. So the first step is to factor out sine u du. So you put aside no sine u du and then change the remaining sine into cosine using the Pythagorean identity, no, this Pythagorean identity, so that you can express the remaining sine function into sum of powers of cosine u. Okay, so that you can easily get the integral no, of these cosine u functions because there's already a du here. No, the sine u du is already present. Okay, so we simply use the formula for the integral of cosine, okay, which is, I mean the derivative no, of cosine. So ready ni for the du, the formation of the du. So derivative of cosine is negative sign. So we just put later no negative signs to neutralize the ano, the multipliers. So we have here the first example. Okay, so the exponent of sine is 7, exponent of cosine is 3. So of course, you cannot just let u be equal to sine of x. Okay, and then express it as u to the power of n because there's no what do you call this? There's it's cube, no? So 3 cosine of x being multiplied and that's just 1. Okay, para ma-ready on that, no, for du. So we need to use the solvable group formula. Okay, solvable groups of trigonometric integrals. Okay, so 7 is an odd, positive, odd, no, integer. So we can use case 1 no, for powers of sines and cosines. So the first step again is to, okay, put sine u du, okay, or sine x dx for this one because x is the variable of integration. Okay, so put one of the 7 sines. Okay, so 7 minus 1 is 6. So what will remain is sine na lang, no? 6, or the exponent is 6. And then cosine is, as is lang muna. Then the sine x dx. Okay, we'll have this ready for the formation of du. So the next step is to transform the remaining sine functions as sum of powers of cosine u. Okay, so using this identity. So we have here raised to the power of 6. So meaning that's sine squared. And then you raise it pa to a power of 3. No? So power of a power rule. So multiply the two powers. So 2 times 3 is 6. And then just copy the cosine function and the sine x dx. So using that Pythagorean identity, so write this as 1 minus cosine squared x. Okay, raised to the power of 3, and then cosine cube, and then sine x dx. So we need to expand this. Okay, so cube of a binomial. Okay, recall. No, so we have u minus b, quantity raised to the power of 3. So that's cube of the first term minus 3 times the square of the second term, the first term rather, times the second term plus 3 times the first term times the square of the second term. And then the last term would be minus the cube of the second term of the binomial. So applying that to the given integrand, so we have the cube of the first term. So 1 cube is 1 minus 3 times 1 squared, or that's 3 times cosine squared x. So that's 3 cosine squared x. Then plus 3 times 1 times square of cosine squared x. So 3 times cosine raised to the power of 4x. Okay, then minus the cube of cosine squared x. So meaning that's raised to the power of 6. Okay, and then cosine cube x sine x dx. So multiply the cosine cube x to each of the functions or the terms in the cube of the given binomial. So we have cosine cube and then minus 3 times cosine raised to the power of 5. Multiply these two, copy the common base, and then add the exponent. So 2 plus 3 is 5. And then plus 3 cosine of x now raised to the power of 7. 4 plus 3 is 7. Then minus cosine raised to the power of 9. Okay, sine dx dx. So we can now let u be equal to cosine x. So du is negative, no, sine x dx. So we need a neutralizing factor negative 1 for each of the terms, basically, because everything here is in terms of cosine x. So we can write this as, so we'll just put the neutralizing factor before, okay, and then transform this into, so there are no other terms, so all are in, again, cosine x, that raised to the power of n, okay? So we put the neutralizing factor na lang before na the integral, so we'll multiply the result with negative 1 later. So we can write this as u cubed, then minus 3 u raised to the power of 5, then plus 3 u raised to the power of 7 minus u raised to the power of 9. Okay, and then we have, so since we place already negative 1 here for the neutralizing factor, so that means we are multiplying na the sine x dx with negative 1. So this will now be our du. So proceed to integration using power rule. Okay, so we have u to the power of 4, no, over 4 minus 3 u to the power of 6 over 6 plus 3 u to the power of 8 over 8, and then minus u to the power of 10 over 10. Okay, then plus c. Okay, that should be enclosed with parentheses, by the way. Okay, so you can distribute the negative signs, or you can just put it before, not the 4 terms. Yes, let's just say not to distribute, and then we'll arrange the terms later. Okay, or we can arrange the terms now, no, starting off with the 8th power, and then we plug in na lang cosine x. Okay, so that we reduce the number of lines for our final answer. So we have a negative of 3 to the power of 8 over 8. That's negative 3/8. And then cosine of x, okay, raised to the power of 8. Or you can write it as this one. So the next term is I. Okay, so we have pati ay, no, the greater exponent, which is 10. So the arrangement is not necessary though. Okay. the arrangement, no, na decreasing order. It's not necessary. Let's just say that I will arrange na the terms in decreasing order of exponents. So we have positive 1 over 10, and then cosine raised to the power of 10. Cosine of x raised to the power of 10, then followed by the 1 with the 8th power, then the 6th power, so that's plus 3 over 6 is 1 half. So cosine of x raised to the power of 6, and then minus 1/4 of the cosine of x raised to the power of 4, then plus c. Okay, so this is the integral of, we have sine x raised to the power of 7, and then cosine x raised to the power of 3 dx. So the second case is if the exponent of cosine is a positive odd integer. So factor out cosine u du, and then change remaining cosine function into sine function using the same trigonometric identity. Okay, then you have here na the integral of the sum of powers of sine u times cosine of u du. Okay, so the cosine of u du will be already, this is used to form the differential. Okay, basically u, no, para we can proceed to applying the integral of sine formula. Okay, so integral of sine is, or rather the derivative. Okay, so the derivative of sine is cosine. Okay, so cosine u du. So for example, supposing we have the same example with case number 1. So we can apply case number 2 as well, because it says the exponent of cosine must be positive, no, a positive odd integer. So 3 is a positive odd integer. So let's apply case 2 and see if we'll get by the same answer. Okay, so we need to express, or we need to factor out cosine u du or cosine x dx, or the du later. Okay, and then express the remaining cosine. So we have 2 more cosine x. We have to multiply. So use the Pythagorean identity, 1 minus sine squared may equals cosine squared. Okay, so just copy sine raised to the power of 7, and then cosine squared. So let me write first the cosine squared, and then applying, okay, the Pythagorean identity na lang below. So cosine is 1, no, minus sine squared. So cosine x dx is placed beside this. Okay. So multiply this and this. So we get sine of x raised to the power of 7. Okay, sorry. Minus sine of x raised to the power of 9. No, 7 plus 2 is 9. Okay. Then multiplied by cosine x dx. So we can now raise, or rather we can set na, no, transform this to u to the power of 7. Okay, and this to u to the power of 9, because we now have the du. Okay, let u be equal to sine x. Wait. So du is cosine x dx. So no need for a neutralizing, no, factor. So we now integrate u raised to the power of 7 minus u raised to the power of 9 du. Okay, so we have u to the power of 8 over 8, or that's 1/8, u to the power of 8. Okay, then minus 1/10, no, u to the power of 9, or u to the power of 10 rather, then plus c, then plug in back the sine x. It's 1/8 times sine of x raised to the power of 8, then minus 1/10 sine of x raised to the power of 10, then plus c. Okay, so let's see if again we got the same answer. Okay, so from number 1, case 1, okay, so it has 4 terms, no, and then the plus c. But as you can see here, for the case 2 answer, it's only composed of 2 terms. But it's in sine, and that one is in cosine. So applying Pythagorean identities, no? So this number of terms can be reduced into 2 terms. Okay. So for every um cosine squared, so you have 1 minus sine squared. So there will be some constant terms. So the outcome would be 2 terms na lang, no? Na you can express as sine squared. Okay. So you can apply no Pythagorean identities. So basically, no, that's the same result no, using different cases. So it's a technique, no? So you have to select a method wherein your solution is shorter. So this, of course, is shorter, no? So instead of getting pa the cube of the sine function, okay, so it's too time consuming. So, mana, so you need to really be koan to really know what are the techniques, and then para you can right away decide on what method to use. All right, so that's case number 2 for group number 2 of solvable groups of trigonometric integrals.